The Brewer's CAP theorem states that only two of the following three guarantees are provided always for a distributed system. So your system might be either of consistent, available, or it may have partition tolerance. So what this means is that consistency of your data set. So you read what you last wrote from any nodes because you have a distributed database. So there might be multiple nodes and you will read whatever you last wrote from any of your node in the network. Availability means that the node will respond if it has not failed. So you have a guarantee of a response. Even if it is inconsistent, there will still be an availability. And the partition tolerance is like a balance of both these things. So it says that your system will continue to operate despite a network partition failure. So this might happen if there's an arbitrary number of messages dropped, delayed, or like something that happens between the nodes. So in case of a network partition failure, your system might choose to either have either of these two following situations. You can cancel the operation to decrease the availability, but still stay consistent, or you can have the operation proceeded, but you can risk an inconsistency, but you will still be available. So we'll move, we'll explain what we mean by this in the following text. So we might not deal with CAP, by the way, in case we have a very good, reliable network, then CAP is not really relevant. So in case of a normal operation, a client can write to a master node, and the master node can copy the data to a slave node, and that slave node can be read from by the client, by another client. So in case we have availability despite despite inconsistency, your client will be able to write the data into a master node even if the link to the slave node is broken. So to the client, the instruction has been like it has occurred properly, but your master node may probably have some link broken. We'll get to why this is not a bad situation in some time. The last case is consistency because of inavailability. So in this case, your client will be unable to talk to the master node if the link from the master node to the slave nodes are broken. So we know about SQL as a relation, like an RDBMS system, your language. So it prefers consistency over availability. So it will tell you that the instruction cannot happen if there's even one link broken between the nodes. And NoSQL will still show you that the nodes are available for certain cases if it does not hamper the rest of the system, but it will show you available even if there is some link broken downstairs, like downstream. So let's discuss what NoSQL is all about. So it is a set of concepts that allows us to rapidly and efficiently process the data set. It focuses on the performance, agility, and reliability. And a very discrete 5 points of NoSQL are that it is free of any joins because it is distributed, but we'll get to that. It has a schema-free way of working, so you do not have any predefined model of how the data should be stored. It works on many processors. It supports like linear scalability, so it can be scaled or distributed if you want to. And it has it uses a shared nothing commodity computer. It basically means that a single node will process a single request. Now, your NoSQL is composed of very simple components. It integrates a large number of modular functions that work together as compared to the traditional RDBMS system, which is a mammoth in compared to this. So in NoSQL, you have one function to share RAM objects, one function to run the batch job, one function to store the documents, and so on. It also has an application layer, which basically means that you simplify the design, like the software design, by reworking the layers that serve different purpose. So it has something like an lambda architecture. It does have lambda architecture, but it has three main layers that we should focus on. So one is a user interface, one is a middle layer, and one is a database layer. In comparison to RDBMS, NoSQL has most of the application functionality in the middle layer. So it can have some key value storage over there, or like some search possibilities or some batch work over there. In comparison to that, RDBMS has much of the functionality added to the database layer. And the middle tier for it was like creation of objects by the user. But in NoSQL, we do not have that. Like the user interface directly contacts with the middle layer where you can directly apply strategies like caching, transaction searching, etc. The performance of the system is sped up by the strategic use of your RAM, SSD, disk, and network. And we use a consistent hashing technique over here, which basically means that you create a hash string or a checksum that is a sequence of letters representing the bytes of a document. It can be of MD5 or SHA-256. It helps to tell if a query or a document exists in the cache of NoSQL. And if two different processors are running on different nodes in the network and they create the same hash for an object, it will cause a hash collision. So one solution to this is just changing one bit of the hash string so that you can store the data on a different hash, on a different key. It helps to assign the document to a specific database node. So this is why it needs a key value kind of storage. Now we come to the idea of an acid or base kind of system. It is a kind of database transaction, like how database transactions should work. Uh, we can explain more about acid and base in the next video, but basic thing is that NoSQL uses a base transaction and an RDBMS uses acid transaction. And the main idea is that with NoSQL, your main information will follow through, and if there's some low significant task that had to be done, that is something that we can forgive. So the user will, if there's a user who has a shopping cart in a mobile app, the payment will go through even if the shopping cart says that your payment has not gone through. So like your money is not stuck in the middle. So there's something like that that NoSQL uses. We'll discuss more about the types of NoSQL data storage and acid and base in the next video.